Hello, I am Swati Anand Bharadwaj. I am from Patna, Bihar. I have done my B.Tech from Haldia Institute of Technology, West Bengal, and I have an experience of 2 years in teaching. So let's begin our today's topic. Today's topic is Rutherford's model of atom. In this, we will learn about alpha particle scattering experiment done by Rutherford. As we know that a number of scientists were studying about the structure of atom. One of the scientists, J.J. Thomson, gave us a famous model named plum pudding model of atom. But he could not explain the results came out of the experiment done by the other scientists. So after that, Rutherford put forward his new nuclear model of atom towards us after his alpha particles scattering experiment. Okay, so let's begin. So for his experiment, he took a lead box container which was containing alpha particles in it, and then he took a gold foil and a fluorescent screen which will detect the alpha particles movement. Okay, so let's begin the experiment. So first he took a lead box in which the alpha particles were kept. What are alpha particles? Alpha particles are positively charged particles, or we can say that they are helium ions, consist of 2 protons in it. Okay, so after that he took a gold foil, because as we know that gold is highly malleable, it can be beaten into thin sheets. So the thinner sheet will be more convenient for us to study about the atoms, because there would be less amount of atoms inside the very much thin sheet. So after that he took a fluorescent screen around his foil, okay, which will detect the movement of alpha particles. Fluorescent screen, it is zinc sulfide coated screen. Okay, it will detect the alpha particles movement. When it will fall on the screen, it will glow greenish. Okay, so let's begin the experiment. When he started bombarding the alpha particles on the foil, he was expecting so many bending, so many deviations of the alpha particles, but the results were shocking. As he was bombarding the alpha particle, he observed that maximum number of alpha particles passed straight through the foil without bending. Okay, maximum number of alpha particles passed straight through the foil without any bending, without deviation. Okay, and then the second observation was that some of the alpha particles got bent at certain angles. Okay, and third and last observation he made was that 1 out of every 12,000 alpha particles, means a very few number of alpha particles rebound. Okay, so on the basis of his conclusions, on the basis of his observation, he made some conclusions, and the conclusion was that from the first observation, he concluded that as maximum number of alpha particles passed through the foil, indicating that what it was indicating, that a lot of space inside the atom was empty. Okay, a lot of space inside the atom was empty. Okay? Because a huge number, a maximum number of alpha particles passed straight through the foil. Okay? From the second observation, he concluded that as he observed that some of the alpha particles got bent at certain angles. Okay? Making small angles. They got bent. So, some of the alpha particles got bent at certain angles, or we can say small angles, which was indicating that the positive charge inside the atom occupies very small space. Okay? As we know that alpha particles are positively charged particles and the same charge repels each other. So on the basis of his second observation, he concluded that the positive charge inside the atom occupies a very small space because the number of alpha particles which got bent was very small. Okay? And the third conclusion made on the basis of the third observation was that one out of every 12,000 alpha particles rebound, indicating that all the mass and positive charge inside the atom was concentrated in a very small volume. Okay? So, since he saw a very few number of alpha particles got rebound after getting stuck on the gold foil, and this was indicating that nearly all the mass and positive charge inside the atom was occupying a very small volume. Okay? So, this was his three conclusions made on the basis of the observations. Okay? So, now we will begin. After this, he put forward his new nuclear model of atom. So, let's move further to the nuclear model of atom given by Rutherford. We'll put the heading nuclear model of atom. Okay? So, nuclear model of atom. And he gave some features also. So, we will write down the features of his new nuclear model of atom. And this model of atom is also known as planetary model of atom. So, first we will draw the model. And we will move to the first feature first. Okay? So the first feature of this model was that after the observations and conclusions he made, forward the features of his new nuclear model. And he said that there was a positive charged center inside the atom called the nucleus. Okay? There is a positively charged center inside the nucleus, inside the atom called nucleus. Okay, atom called nucleus, and nearly all the mass of atom is concentrated inside the nucleus. Okay, nearly all the mass of atom is concentrated inside the nucleus. Okay. His second feature of his model was that the electrons revolves around the nucleus, and that's why this model is also known as planetary model of atom. Okay, so the electrons, that is negatively charged species, electrons revolves around the nucleus. Okay, as the planets revolves around the sun, just like that electrons revolves around the nucleus, the positive charge. Okay, so, and the third feature was that the nucleus is very small as comparison to the size of the atom. Okay, so the size of the nucleus is very small as compared to the size of atom. So this was his nuclear model of atom and the features of his model. But there was a drawback of his new model of atom, and that was that he could not explain the stability of atom, as later it was found that any charged body or species which revolves or moves in a circular path radiates its energy because it undergoes acceleration. So if the electrons would radiate its energy, its orbit would start getting smaller and it will fall inside the nucleus, and due to this our atom will be collapsed. So he could not explain the stability of our atom. So that's all for today. Thank you so much.